Hey everybody, it's Peter from Hacking Math. Last week I was subbing for a Precalculus teacher nearby on Friday, and they were learning something called trigonometric identities, and the students weren't finding it all that rewarding. So you just have to get the left side to look like the right side by changing things into sines and cosines and using trigonometric formulas. So if both sides equal secant, well, great, you can go on to the next one. So I was thinking to myself, how would I teach pre-calculus? I loved trigonometry when I was in school, so how about something like this? As you can see, that's a wave of colorful circles. And how would you create that? Obviously, you need to know a little bit of programming. You'll see how little in a few minutes. But if you could make a circle, you could make a bunch of circles, right? Now this is all about location, location, location. And if you just focused on one of those circles, you'd see that it just goes up and down. It doesn't have any side-to-side motion or anything. It's just going up and down, all of them. But each one of them is just a little bit behind the next one, or a little bit in front of the previous one. So how would you do that? Now my favorite graphics package is called processing. And if you go to processing.org, you can download it for free. This is the Java version with all the Java functions and variables and whatnot. There's also a very good JavaScript version, which I like very much. The Python version is here. They've got all the tutorials that you could look at, and most importantly, they have the reference. So you can use all these tools or just use one of them like I will. I'm going to use circle, that's all. So to put it on the screen, all you need is 3 numbers. Which 3 numbers do you think we would need to give the computer to draw a circle on the screen? And sure enough, it says there, you've got the x-coordinate of the circle is the first number. The second number is the y-coordinate of the circle. And the third one, extent. I don't know why they call it extent. It's actually the diameter of the circle, the width and the height. As in every graphics package, there's some boilerplate code that you have to put in. And in processing, it's setup and draw. All the versions, you need to have a setup function and a draw function. And the setup function is run once at the beginning of the run. And here's where you tell it the size of the window. If you want to change the color of the lines, that's the stroke. Oh, and the background. So you tell it the background colors and stuff. The draw function is the infinite loop. So that keeps looping, and here it's going to keep drawing a line, and your screen refreshes, I don't know what, hundreds of times a second or something. So that's how that works. So we just need setup and draw, and some of these. We have circle, and we'll use size and background. We'll even use some colors to make it pretty. So I started up processing, and I've got this blank canvas, and we're going to define the setup function and the draw function. Okay, we've got it set up, and we're going to draw a circle at 0, 0, and its diameter is going to be 20. When we hit run, what happens? Here we go. We have a 600 by 600 screen, and here's where 0, 0 is. It's way up there in the corner. So that's where 0, 0 is. X goes up as you go to the right. That's standard from math class. But y goes up as you go down the screen. So that's common to a lot of graphics packages. So if we want this to come down the screen, maybe we want it to be in the middle here, which is 300 for y. So x can still be 0. Now when we press run, we should see a circle halfway down the screen, all the way to the left. All right. Now what? Now we need to make a bunch of circles. How do we make a bunch of circles? Well, we're going to have these circles going along here. If each one of them is 20, we might want to make this a variable so we can change the size of them. Well, we'll just keep it at 20 for this tutorial, but you can change that. So the centers of the circles are going to be at 0. This one's at 0. This one is 2 radii, or 1 diameter from that one, which is 20. So this one's going to be at 20. This one's going to be at 40, 60, 80. So now I know all the locations of the circles. Now, do I have to... Now, am I going to have to draw, type out circle a bunch of times? Circle 20, 20, 300, 20, and circle 40. Or do you see a pattern that we can extend? Sure. X is going up by 20 every time. And to draw a bunch of objects or to do something a bunch of times in any programming language, you would use a loop. In Python, how you use a loop is for I in range. That's just traditional. For I in range. And then we've got 600 by 600 and 20 by 20. So maybe 30 circles will do it. We don't need any of these other ones. Let's just explain what this is for a second, real quick. Range is a bunch of numbers. So we could have said for I in 0, 20, 40, 60, and so on. But range does that for us. Well, it gives us from 0 to 29 in this case. It gives us 30 numbers. And each one it stores in this variable I. So we can use that variable to make the skip 20 each time. Easy, right? Let's see if it works. Right on. I think we're missing one at the end, so we might just want to do 31. How about that? But it worked. Excellent. Now we can make a different background every time. Zero is the grayscale for black. You can make it white. You can make it any color you want. There's black. I think, let's see, it's RGB, so no red, or we could do all red. Red, no green, no blue would be all red. So that's going to be shocking, yeah? If you like red, you can make it red. I'm going to keep it as black. Should look fine. Yep. Now we need to make them move. Remember, each circle just went up and down. So this is where the precalculus comes in, or trigonometry, because sine is not really just used for angles of a triangle or the ratios of the sides of a triangle. Almost never. More often now it's used for oscillating motion, a sinusoidal wave. So that's what we want to do here. So all we have to do is to change this in a way that I would hope that a precalculus student would know how to do, in that you've got your center, which will be 300, and then we're going to go up and down sinusoidally, plus the sine of some time variable. So we haven't defined t. You might see this error message when you code. Global name t is not defined. Yep, I have not defined that yet. So I'm going to define it in setup. Set t to 0. And to share it with other functions, I have to set it as a global variable. So global t, now you can use it. And then we change the time. At the end of the loop, let's make t go up by 1 for t seconds or t frames. T is referenced before assignment, so I have to tell it you're using the global t. All right, and it's working. Can't you see it oscillating? Sine goes up to 1 and down to -1 and keeps doing that. Up to 1, down to -1. So that's what it's doing. It's going 1 pixel up, 2 pixels down, 2 pixels up. So you can't see it very well, or it's definitely not as rewarding as the other one. How are we going to make this go up 100 or 200? All you have to do is multiply what comes out of the sine function by the amplitude. Amplitude is the size of the wave that we want. So this is a good point to know. Why would we need more amplitude? Well, you don't want just this little wave going up and down by 1 pixel. So here's where we do that. This is a 600 by 600 screen, so 300, is it going to go off the screen a little? We can change that however we like. Ooh, boy. I know for the first thing, we want to slow that down. But it's probably not too bad. Let's see, maybe 250 up and 250 down. Okay, let's slow that down. There's 2 ways we could do that. We could either change the amount that t goes up by, or we could do something very mathematical, or more mathematical, and change the frequency. Now the frequency is just multiplied by the time. You multiply the time by some number. In Precalculus, you'll see 2t or 3t, something. That'll make it go faster. We don't want that. We want to make it go slower. Maybe we'll multiply it by 0.1, dividing by 10, for example. We'll see if that slows it down. Okay, that slows it down maybe a little more. 0.05, and every frame it's calculating, okay, the sine of that, multiplying it by 250. Every frame it's doing that. Those are completely different ellipses. I'll show you. If we comment out that background, we're just going to see all the ellipses that are being drawn. And there they are. Thousands, millions of ellipses. But when the background line is operational, it's setting the background to black and then drawing the circles. So it looks like these circles are going up and down. Good illusion. Got me fooled. Now we don't want these circles to be right next to each other. Of course, we want them to look like a wave. So we want them to be a little bit ahead of each other, a little bit behind each other. Remember, each of the circles has its own value for I. Remember when we declared the loop, each circle has its own I. One is 20 times 1, and 1 is 20 times 2, and so on. So we could use I here and take away a certain amount of I from the time before we take the sine. So if we subtract I, what does it look like? Okay, we have a wave. They're a little bit too far away from each other. in front of and in back of each other. What if we divided that by 10? And dividing in Python usually gives you an integer. I think we'd have a whole bunch of ellipses right next to each other. Yeah. So you have to use a decimal to make it, to give us decimals. There it is. What if we made that into 5? I think they would be closer to each other. There we go. Okay. Something in between that? 7? Yeah, that looks good. Now, what if we want colors? And of course, colors are dealt with in the processing reference. So if we click on the reference and we look at colors, here's the background and fill. Fill is the color. That's how we get colors, and there's 4 numbers possible, like an R, G, B, and then an alpha is like a transparency. So for color mode, we could use RGB values. A certain amount of red, a certain amount of green, and then a certain amount of blue. But in order to get the rainbow colors that we had in the example, we would have to change all 3 colors. There's another color mode called HSB. It's hue, which is what we want. Hue means color. S is for saturation. I'm really not sure what that means. And then B is brightness. So we'll change the hue and we'll leave the saturation and the brightness maxed out at 255. First we have to tell it to make the color mode HSB. And then give us the fill that's, say, 20 times I. We might change that around. We'll see what it is. We'll see what that looks like. And the saturation and brightness are maxed out. There we go. Yep, we have a rainbow, and then it ends pretty quickly, so I think this should have been, say, 30 I. Maybe it's 40. Oh, it's going the wrong direction. Maybe 10 I. 7 I. That looks good. So for all that code, we have under 20 lines of code. We're using some math. We're using some computer programming concepts, loops and variables and whatnot. And this is the kind of thing that I could bring to your class, show you how to do this, or show your teacher how to teach this way. I'm also available for private tutoring in person or online. I'm in North Texas. And check out my webpage, hackingmath.com, and like and subscribe. And it'd be my pleasure to see you next time. Bye-bye.